Right, welcome to week 4 of Water Distribution 2. This week we are going to be going over math. The lecture itself is kind of lengthy, so I am going to break this up into 3 different videos for you. So that way it's a little more digestible. You don't have to take it all at once. Kind of spread it out and get the most benefit from it. So that being said, let's get started. All right. So, why math? Well, obviously we use a lot of math in this industry, so that's why you need to know it. Okay, it's something that's applicable in every single field within the water industry. So, as you can see here, for meters, we use it for billing, detection, leak detection, flows, even your electrical meters. So, there are chemical disinfection dosages, you got storage reservoirs. The math is, spread out throughout the entire industry here. So obviously we got a lot of flow rates, velocities. There's, you know, these numbers you actually use in the water industry. Okay, so it's not just to punish you guys and make you, have to do math, but this stuff is really applicable. Anytime you have a main break, you have to calculate out water loss, and how you go about that varies from agency to agency. But I mean, it's a best guess, and it's needed because you have a water loss budget. So being able to calculate water loss is important. Obviously, you want to be able to calculate pressure. I've had to calculate pressure, I think, more times than anything else I've had to do in this industry. So become very familiar with that. You get a lot of people who are going to complain about the water pressure at their house, and you want to be able to know what the theoretical static pressure is at their house prior to getting there, or upon arrival, however you do that. But being able to calculate that number is important. And then, like I said, you know, regulatory reporting, obviously, there's a ton of that in this industry, so you may as well just accept the fact that you need to know how to do math. As you can see here, when you're operating a distribution system, you need to know how much volume, you can fit into each of your reservoirs. You got to know, what kind of flow rates do you need from your pumps. So if you know that you need to, put 10 feet of water in a reservoir, and your pumps are only flowing at, let's say 1,250 gallons per minute. How many pumps do you need to use in order to achieve that in a, let's say, 10-hour time frame, right? So math is used in your daily life as a distribution operator. Obviously, there's different units of measurement with every different math calculation. So obviously, what would math be without abbreviations? So if you don't know these ones, you should probably become familiar with them if you haven't already. You could see that each unit of measurement can equal the same. It's just a different number. So like in the example here, 694.4 gallons per minute equals 1 million gallons per day, which is the equivalent of 1 million gallon per day, which equals 1.55 cubic feet per second. And then same with this one. You've got 10,000 cubic feet, which is the equivalent of 74,800 gallons, which is the equivalent of 0.0748 million gallons, or 0.23 acre feet. So unless specifically instructed otherwise, or because dimensional analysis calls for an exception, dimensional analysis is just the units of measurement in your problem. Surface areas and volumes must be converted to feet. It's a more standard unit of measurement in America. All right. So if you have, let's say, any number of inches, really, you want to divide that by 12 inches per feet. So the common units of measurement would cancel each other out. and you're left with however many number of feet that number would have represented. So, like in the case of 1 mile, 5,280 feet is the equivalent of 1 mile. All right. You've by this point you should have seen the state conversion sheet if you haven't already. But becoming familiar with it is going to save you time when you're taking a distribution exam. So it's beneficial to you to learn it, and then as time goes on, you might even develop your own conversions, like we're going to look at right now. On the left side here, you can see I've got just this quick little problem here. 3 times 0.0646 equals 1.94 million gallons, right? So where did that 0.646 come from, right? Well, if 1 CFS is the equivalent of 7.48 gallons per minute times 60 seconds, then you're left with 448.8 gallons per minute, right? And that in and of itself is a shortcut. But if you take that same 448.8 gallons per minute and you multiply that by 1,440 minutes per day, then you're left with 646,272 gallons per day. You divide that by 1 million, and you're left with that 0.646 million gallons per day. And so that's just a short conversion. Or that's something that you can learn to save you time when you're doing math problems. So just having a basic understanding of where these numbers come from, in addition to following your units of measurement, will save you time as you're taking a distribution exam and doing the math portion. All right. So where did 7.48 come from? And so we know that 1 gallon of water weighs 8.34 pounds. So if you have 1 cubic foot, that is the equivalent of 1,728 cubic inches. And if 1 gallon of water contains 231 cubic inches, you take 1,728, divide that by 231, you're left with 7.481 gallons per cubic feet. So that's where that number comes from, if you didn't already know. All right, so if you were to multiply that 7.48 gallons by 8.34 pounds per gallon, your gallons cancel out and you're left with 60 or 1 cubic foot equaling 62.4 pounds. All right. 7.48 gallons per cubic feet. You multiply that by 60 seconds per minute, you get the 448.8 gallons per minute, 449 rounded. If you use either one, usually when you're doing math problems, you're allowed a range because sometimes the answer can vary depending on when you hit the enter sign or the equal sign. So typically when it comes to math, there is some sort of a range involved in it. Um, so if you use 448.8 or if you use 449, you're going to be safe. So it's okay to have that variance in there. Anyway, if you were to use 448.8 gallons per minute times 1,440 minutes per day, you're going to be left with 646,700 or 272 gallons per day, right? So if you know where those numbers come from, you can skip right to it. Again, it'll save you a little bit of time, right? Anytime you're doing a pressure or anytime you're doing a problem where either pressure or feet of head are involved, just knowing that feet of head, if that's the unit you're trying to calculate, um, is always going to be a greater number than the PSI, right? It's just the sheer number will be larger than the number you would get if you were calculating PSI, and vice versa. If you are trying to solve for pressure, that number, that sole number will be smaller than the number you would have gotten if you were calculating for feet of head. So just having that understanding can help you, to get you the correct answer. If you know that you're, in the equation itself, it's giving you, let's say, 200 feet of head, solve for pressure. Well, if you were to divide that by 2.31, you would get a smaller number. So you should feel confident that you're solving it correctly. However, if you were to say multiply it by 2.31, you would get a much larger number. And that should be an indication or something should be going off, a red flag to let you know that, hey, that number is not correct. So just pay attention to those kind of things as you're working through your math problems. All right, like I said before, I use that word dimensional analysis. Here's an example. You've got length times height. It doesn't matter if you're calculating length times height or height times length. Either way, you're going to get the same number. Just like with cubic dimensions, right? You have three values of equal dimensions that, or not dimensions, but units of measurement that will give you a cubic figure, right? So let's say you have a reservoir that is rectangular. Well, this one's actually pretty much a cube, but anyway, you would multiply width times height times depth, and that would give you your area in cubic, whatever, inches, feet, miles, however large that is, right? So you want to make sure you like pay attention to what the unit of measurement is that they're asking for. So, in the example here, 24 times 16 times 10, you're going to get 3,840 cubic feet, right? Because feet times feet equals cubic feet. And then if you wanted to solve for gallons, well, we know that 7.48 gallons per cubic foot is how many gallons are in a cubic foot. And you multiply that by the 3,840 cubic feet, your gallons would cancel out, and then or excuse me, your cubic feet would cancel out, and you'd be left with the gallons, and that answer is 28,723. Circles are a little different, or anytime you're solving for this, because there is a number that you are going to multiply by. However, it does not get, let's see, how do I say this? It doesn't get included in like the cubic feet, if you will, or square feet calculation. So what I'm talking about is this number here, this 7.8 or 0.785 number, right? And so if you can imagine that there was a square around this circle, right? That 0.785 only accounts for everything inside of this circle, right? The remaining, what's that? One, 2.1 or point two, yeah, 0.215 uh, is those corners that you would cut off from the square because you have two numbers that you're multiplying by. So let's say it's 12 times 12, right? So 12 times 12 is 24, or excuse me, 144, and then you would multiply that by that 0.785, and you would eliminate that amount, and that comes out to one. So your answer would be one. But that's what that 0.785 represents is just the area within that circle. Down here under, if you're solving for circumference, obviously it's just going to be the diameter, which is the length from one end of the circle to the other, times 3.14, which is a constant, and that will give you the circumference. All right, so if we're calculating for 1 cubic yard, right? So how many feet are in a cubic yard? Well, we know that 1 yard is 3 feet. So if we go 3 feet, and we're solving for the cubic yard now, if we go 3 feet times 3 feet times 3 feet, we're going to get 27 cubic feet, right? So if 1 gallon of water weighs 8.34 pounds, how much would 1 cubic yard weigh? Well, how would you solve this one? Yes. You would take 8.34 and you would multiply that by 7.48 gallons per cubic feet, which would give you 62.4 pounds per cubic feet. And then you could multiply that by 27 pounds per cubic feet times 0.7 cubic feet. You get 1,684.8 pounds. Much heavier than anyone could lift. All right, moving on to temperatures. You will see these kind of questions in your distribution exams and then throughout this course too. But knowing how to convert from one to the other, it is more important than it just sounds. It's not just again more problems for you to solve, but there are analyzing equipment that will only measure in Celsius, and so knowing how to convert that to Fahrenheit is important. If you find yourself in a lab setting or if you're out in the field testing and your field test equipment only measures in one or the other, it's important to know how to convert those. All right. So to solve for that, if you were solving for Fahrenheit, let's say, and you had Celsius, you would, F would represent Fahrenheit, and you would multiply 9/5, or excuse me, yeah, it's actually, yeah, 9 over 5 times the number of Celsius degrees plus 32. And then the inverse of that would be Celsius equals 5/9 multiplied by whatever Fahrenheit is minus 32. Here's just another example, those same equations. Kelvin and Rankine, those are different units of measurement. Typically, those deal with like absolute zero. Rankine you're going to find in like an engineering setting or thermodynamics is where that is utilized. But again, it's just other ways to calculate temperature and convert them from either Fahrenheit to Fahrenheit or from Fahrenheit. All right. So how can we create shortcuts to minimize the amount of time that you're spending working on your math problems? Well, if we know that 9 divided by 5 equals 1.8, that can save you just a smidge of time, right? So for the example here, your problem is that your equipment only reads in Celsius and it has a reading of 18 degrees. So how do you convert this to Fahrenheit? Well, you have your formula, so plug in the numbers and play, right? So you could do 9 divided by 5 times 18 plus 32, or if you already know that 9 divided by 5 equals 1.8, you could just go 1.8 times 18 plus 32, and that will get you Fahrenheit. So your answer is 64.4 degrees Fahrenheit. All right, let's go over some of the stuff that we just covered. Like I said, this is part one of three. So here we go. You're filling a water storage tank that has been down for repairs. You need to add 2 million gallons of water to the tank in exactly 24 hours. How do you solve this problem? Well, you got to first recognize what is it that, you know, they're asking you for. So in this problem, they're asking you how many gallons per minute will you need in order to solve, or in order to add 2 million gallons in 24 hours. You have two different units of measurement here. You have one in minutes and one in hours. So first thing we want to do is convert hours to minutes to have the correct unit of measurement. How do we do that? All right. Well, in 24 hours a day, if you were to take 24 times 60 minutes per hour, you would get that 1440. And then we know that, we're trying to add 2 million gallons in 24 hours. So if we take 2 million and divide that by 1440, you're going to be left with 1,389 gallons per minute. That would be your answer to this question. All right. So if we take that same number of gallons per minute, and let's say that this time we are asking for cubic feet per second, so let's take it a step further, right? When you make flow changes, at least with the water authority, those flow changes are going to be made in cubic feet per second, not gallons per minute. However, if you're dealing with a much larger volume of water, the flow changes might be in million gallons per day, or million gallons, or acre feet per day, depending on the size or the volume of water that you're needing to make your flow changes in. So get back to this problem here. Your flow orders are made in cubic feet per second, not gallons per minute. How many cubic feet per second will you need to add 2 million gallons in 24 hours? It's essentially the same problem, but just looking for a different unit of measurement. However, we already solved for gallons per minute, right? So we had that 1,389 gallons per minute, right? If we divide that by 7.48 gallons per cubic feet, and then divide that by 60 seconds per minute, you're going to be left, or you can, again, remember we talked about shortcuts. We talked about, 7.48 times 60. See, yes, equals 449. Let's see, did I mess this up? Let me see what we get here. Yeah, okay, that's right. Um, Yeah, because I already have the minutes over here. So yeah, you would want to divide that by because you have that unit of measurement of minute here, and we're trying to get CFS, right? So we're trying to find things in cubic feet per second. So minutes divided, so this is 60 seconds per minute. So the minutes cancel each other out, the gallons cancel each other out, and we're left with cubic feet per second. And so that is the 3.1 cubic feet per second. Or if you have this number here, you can, which is gallons per cubic feet per minute, then you would solve for that. And so basically the minutes would cancel each other out. You're left with, and the gallons cancel each other out, and you're left with cubic feet per second, which is the same number. All right. And like I said, depending on your volume, it could be as large as acre feet. And so here's a number that you should be familiar with by now, but 1 acre foot of water is the equivalent of 325,829 gallons, right? So 2 million divided by the 325,829 gallons per cubic acre foot will give you that 6.1 acre feet. So anyway, you can see that um, you just got to pay attention to the units of measurement that they're asking you to solve. And that will keep you on track. And so that way you can ensure that you're solving for the correct unit of measurement that is being asked of you. All right. Next, we're going to dive into pipe diameters, flows, and everything. So that will be on the next video. Thanks.